Hi guys, so this video covers question number 9 of paper 1 2015. The links to the paper and the memo are provided in the description, as well as the handwritten notes. So if we take a quick look at question number 9, it says we get given h of x is equal to some cubic function, and g of x, which is just equal to a straight line. We get given p and q and their turning points, and they pass blah 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 blah. Show that a and b, so we've got to figure out what that a and that b is for 5 marks. It says calculate the average gradient, okay, and then show the concavity changes significantly. Okay. So let's start off by writing down what the question is. So question number 9, we have h of x equals negative x cubed plus ax squared plus bx. And then we have g of x. I personally prefer writing it out on my own page first, so even in the exam I'll write it out because it gives me it allows me to break down the question, because sometimes the questions are a lot of words, and if you write it on the page yourself you can actually get a nice clearer understanding of what exactly is going on. So write it down, and they say that we have points P and Q. They haven't told us what P is, but they tell us what Q is, which is points 2 and 10. And they say that these two are turning points of h of x. Very useful. And they say the graph h of x passes through the point 0, 0. Right, so that makes life quite simple. So these are the 2 bits of information they give us. They say it passes through the point 0, 0, that's the origin, and they give us some point P, which we know is x, y, and they give us some point Q, and they've actually been nice enough to tell us what the thing is, and they've told us that it's the turning point. So the first question, 9.1, says show that A, this A over here, and that B is equal to 3 over 2 and B is equal to 6. So how do we go about showing that? Well, the first thing we have to do is say, well, what have we been given? We've been given an equation. We said that is a point, it's a turning point, and that is a point, but this origin is not going to do us any good, because 0, 0, 0, 0, that's quite easy to see. So we actually only have 1 point. So how on earth do we use that 1 point to calculate 2 unknowns? Well, we've got to be clever about it. So you do remember that every single time you have 2 unknowns you need 2 equations, and that means you need 2 points. So let's start with the first point. Let's start with point Q, which is at 2 and 10. So if we start with point Q, we say, well, the y value is 10 and the x value is 2. So negative 2 cubed plus a times 2 squared plus b times 2. So we get 10 equals negative 8 plus 4a plus 2b. And we solve for our a and b, and we can see that, well, we take all these things across, and it works out to the fact that we take the 8 across and we get 18. So 18 equals 4a plus 2b, and you can then divide everything by 2 because, well, it's all divisible by 2. So we see that 9 equals 2a plus b. Now that's, you don't really have to, but it works out a bit nicer if you do that. And we say, okay, well, that's our first equation. We can, if you want, you can say, well, b is equal to 9 minus 2a. If you want to solve specifically for b, which probably have to do in the end anyway. And we say, okay, well, we've got that. And now we say, but where's the second point going to come from? The second point comes from the fact that they've said that the turning point of h of x is equal to p and q. How do we find the turning points? Well, if we look at our graph, if that's our graph, there's a turning point and there's a turning point. And what is that? What is that? How do we find that point? Well, we take the derivative. Okay, so the derivative set to 0 will give us that point. At least, will give us the x value at that point. So that's what we've got to do. We've got to take the derivative, which is h dash of x, set it to 0, and then we will get the x value at that point. So the graph, I've actually drawn the whole graph wrong. The graph actually looks like that. So let me just remove the red graph because I've drawn it completely wrong. And this is our point Q, which is at 2, 10, and this is our point P, which is x, y. And if we take the derivative, set it to 0, we are going to get this 2 value. So take the derivative of this, which is negative 3x squared, negative 3x squared, so negative 3x squared, plus 2ax, plus 2ax, plus b. Right, so we take the derivative, plus b, and that's what we get. And if we set this to 0, we know x must equal 2, right? So we know x equals 2 because normally what you do is you say, well, if that's 0, what is the x value? Now we have the x value. We're trying to find the actual equations. So that means it's negative 3, 0 squared plus 2a, sorry, not 0, x is 2, apologies, 2 plus b. So 0 equals negative 3 times 4, which is negative 12, plus 2 times 2 is 4a plus b. Right. Now there's a couple of ways you can do this. Call this our second equation. You can solve this by doing either, well, I might as well do them all. Either subtracting 1 from 2. So you can either take 1 minus 2, and the reason we can subtract them is because there's a single b. B's are the same in both. If the number 1 had a b, 2b, and then a number 2 was 3b, can't do it because they won't disappear, because the values have to be the same. So in this case we have, I'm going to take the 12 across, so we have 12. Well, let's just do number 1 first because that's the order that I wrote it. 9 equals 2a plus b minus this thing, which is number 2. 12 equals 4a plus b. And if you notice, because b's have the same value, that goes to 0. B minus b. 2a minus 4a is minus 2a. And then 9 minus 12 is minus 3. So you can say, well, a is equal to 3 over 2, which is what the original question said we must show. 3 over 2. And then obviously b, therefore b is equal to, and you substitute into your equation this guy, 9 minus 2a, 9 minus 2a, which is equal to 9 minus 2 times 3 over 2. The 2's cancel. 9 minus 3 is equal to 6. So we have our b and we have our a. If you do not like doing this subtraction thing, which I know a lot of people don't, I personally don't, because it only works in certain cases, like this one that we showed you. What I prefer to do is I prefer to say, well, let's substitute 1 into 2. But then I must use this as my number 1. And we say every time we see a b, we substitute 9 minus 2a. So we get negative 12 plus 4a times plus b, sorry, 0 equals, And every time we see b, we must substitute 9 minus 2a. Now we can solve for a. So 12 equals 4a plus 9 minus 2a. Take the 9 across. 12 minus 9 is 3 equals 4a minus 2a is 2a, and a equals, well, 3 divided by 2, which is what we expect. And then we can substitute back into our original, and we say, well, this is, call that our third one, and you can say 3 into 1, and then we do exactly the same thing here. We say b is equal to 9 minus 2a, and that's 9 minus 2 times 3 over 2, which is equal to 6. So whichever way you feel comfortable with. I personally prefer the method written in blue, but it's completely up to you. Right. The next question, and that was 5 marks, so that's not too bad. The difficult part was realizing that it was the derivative that you're supposed to be using. Okay, so 9.2 says calculate the average gradient of h between p and q if it is given that x equals -1 at p. When they say average gradient, all they are saying is we have some graph, 9.2, we have some graph, we know the graph looks like this. There's our q, which is sitting at 2 and 10, and they've given us our x value of p, which is at 1 comma some y value. We can calculate the y value, we just plug it into our equation and we get it. But when they say average gradient, what they mean is they mean take a line, connect those two dots, and find the gradient of that line. That will give us the average gradient between those. If they had said the word instantaneous gradient, so specifically instantaneous, that means that you must take the derivative. But because they specifically asked for the average gradient, we literally take a line, draw that line, and say m is equal to the change in y over the change in x. That is the average gradient. And that's very important. If they had said instantaneous gradient, then you have to take the derivative. So we know what our px value is. What is the y value? So we look at h at 1, h of x at 1. We see it's -1 cubed. We know the a value because we've just worked it out. So it's plus 3 over 2 times x squared, which is 1 squared. And then, sorry, it's -1, not 1. -1. Plus b of x, which is 6 times -1. Okay, so we've got to figure out what our y value is. You take that, you plug that into your calculator, and you get -3.5. Now, it is important to put all these brackets, otherwise you're going to get all sorts of weird negative things happening, and it's going to get all confusing. So keep your brackets in, put your brackets in your calculator. We get the y value is -3.5. So let me just put that here, -3.5. Don't have much space, let's actually make it a little bit nicer. -1 comma -3.5. Right, so how do we get a gradient? Well, gradient is calculated by saying, as we've got over here, m is equal to the change in y over the change in x. And the change in y over the change in x, m is equal to y1 minus y2 over x1 minus x2. Now, what is the y1? Well, we know what the y1 is. We can either choose q or p. I'm going to choose q as my y1 because it looks nicer. 10 minus my p value, which we've just calculated, -3.5, divided by x, which is 2, minus -1. It's very important that you include these brackets, otherwise you get it wrong, and it doesn't matter which way you do it. If you had said -3.5 minus 10 divided by -1 minus 2, you get the same answer. And you plug that into your calculator and you're going to get 4.5. And you have to get a positive answer because, as you can see with this graph, it's a positive gradient going between those 2 points. Okay, and that was for 4 marks. 4 marks for that. You get a mark for this. You obviously get a mark for the substitution. You get a mark for your final answer, and you get a mark for that. So that's, quite honestly, that's 4 free marks. Let me just add a new tab. Right, 9.3. So 9.3 says, show that the concavity of H changes at x equals a half. Now, what do we mean by concavity? So concavity is, if we look at our graph again, and our graph does that, we've got a point of inflection over here. This, and the point of inflection is when the second derivative, so point of inflection, we take the second derivative, and the point of inflection is where the concavity changes. So if we want to find the change in concavity, we need to find the point of inflection, and to do that we take the second derivative and we make that equal to 0. I don't know if I'm going to explain that in this video, probably not. I'll post another video explaining a little bit more of changing concavity and things like that. So for now you'll just have to take my word for it. But the point of inflection is where the concavity changes. And if we look at concavity, that is concave down and that is concave up. In a previous video of mine I mentioned that when the second derivative, where this is obviously f of x, the second derivative is greater than 0, we have concave up. Where the second derivative is less than 0, we have concave down. And that's an important thing to remember. Where f of x, the second derivative, is equal to 0, we have a change in concavity, or a point of inflection. That's not point of interest, that's point of inflection. And what that means is that the gradient goes from a decreasing gradient to an increasing gradient, or you end up with from a concave up to a concave down, or a concave down to a concave up. So that is very important. You need to know these 3 things. Like I said, I'll probably explain it in another video, exactly how that works, but for now just need to know that. So that we need to answer the question. So it says, show that the concavity of H changes at x equals a half. So in other words, if we take the second derivative, H dash, also take the first derivative to start with, so H dash, well, let's just write what H is so we can carry on. H of x is equal to, we have negative x cubed plus 3 over 2 ax, not ax, that is a, 3 over 2 x squared plus 6x. That's the equation that we got from earlier. H dash, so the first derivative, is equal to negative 3x squared plus 3x plus 6, and the second derivative, which is the one that we want because we're looking at concavity, is negative 6x plus 3. And like I said, when it is 0, that's what we're looking for. So when the change in concavity occurs is when the second derivative is 0. So we let that 0 equal negative 6x plus 3. Take the 3 across. Negative 3 equals negative 6x. So therefore x equals a half. And like they said show that it happens at x equals a half. So we've just shown that it happens at x equals a half. The next question is a bit of a weird one. So this is 9.4. 9.4. The next question says, explain the significance of the change in question 9.3 with respect to H. Now, that's kind of weird. So all they're asking is, what does that mean when there's a change in concavity? It simply means, as I've mentioned, that there is a point of inflection at the point x equals a half. And if you look at the memo for this, it says the graph changes from concave up to concave down at x equals a half, or the graph has a point of inflection. It's kind of a silly question, because I don't see the point of it really. Anyways, we look at 9.5. It says determine the value of x given that x is less than 0. So let me just bring it up. It says determine the value of x given that x less than 0, or given x less than 0, at which the tangent to h is parallel to g. What does that even mean? So what that means is we need to say, when is the tangent to h parallel to g? And if you remember what g is, g of x, which was completely forgotten in this question, is negative 12x. And that guy there is the gradient, and that defines if something is parallel, because parallel lines have the same gradient. Right? We remember that from our basic geometry. Parallel lines have the same gradient. So if we get a gradient of negative 12, well, then they're parallel. And how do we determine the gradient of a line or a graph? We take the first derivative. The first derivative is the gradient. If you don't understand that, go see my video on calculus first principles. It explains that. So the gradient of the graph of h is equal to the first derivative. Now we don't even have to do it again. It's right over here, because we did it in the previous question. Negative 3x squared plus 3x plus 6. So we've taken the derivative, and we say, well, when they're parallel, the gradients must be the same. So negative 12 must equal negative 3x squared plus 3x plus 6. Remember, this is equal to their gradient. Right? When the gradient is 0, we have turning points, but the gradient isn't always 0. The gradient could be any number, depending on what the graph is. So we solve for this. Take the 6 across, and we get, or let's actually take the 12 across. 0 equals negative. In fact, hold on. Let's just divide by this negative 3 just to make life easy. Negative 3, negative 3, negative 3. And remember, you got to divide everything by negative 3. And I'm dividing by negative 3 because I want to get rid of that whole negative thing. Obviously, you'll probably just plug it into your calculator, knowing you guys. But we want to do it properly. 12 divided by 3 is 4. That's just x squared minus x minus 2. We take that 4 across. 0 equals x squared minus x. Minus 2 minus 4 is minus 6. And we can work that out to say factors of 6 include 3 and 2. And then negative 3 plus 2 equals negative 1. So we have x, we have x, we have 3, we have 2. There's a negative 3, a positive 2, and that'll give us our answer. So x equals 3 or x equals minus 2. And that makes sense, because if we have a graph, let me just draw it out, that looks like this, and we've got another graph that looks like this, not quite like that. This is h of x, that is g of x. Well, the gradient could be the same at this point. Let's just go to a different color, and it could be the same at this point. Alright, so there are 2 points on this graph where the gradients are equal, and therefore the lines are parallel. Now, which point do they actually want? Well, they're specifically asking, if you go back to the question, they're specifically asking for when x is less than 0. And x is only less than 0 in that one. So therefore, you'd simply say x negative 2. Only, not that one. Okay. And that brings us to the end of question number 9.